Writing, non-com, Excel add-ins in Delphi. Writing Excel add-ins with Delphi is a challenging project. I show how it can be done, and highlight the various pitfalls waiting for the unwitting traveler in this largely unexplored frontier. Writing Excel add-ins with Delphi is a challenging project. Here where I show how it can be done, and highlight the various pitfalls waiting for the unwitting traveler in this largely unexplored frontier. Despite Microsoft's apparent unpopularity in some quarters, Excel really should place high on lists for best software ever created. Of course, taking well over 10 years to get it right helped. I think that a particular strength of Excel is its relatively open API, allowing developers to create macros and use Visual Basic for Excel/VBA for apps. One of the lesser-known Excel features is add-ins. Though you can create them with VBA, but you can also write add-in Dlls in C++ and Delphi. For those doing serious development, you need to buy the Excel 97 Developers Kit, ISBN 1-57231-498-2, EDK, book, but of course it's C/C++ oriented and there are some traps for the Delphi programmer. In this article I show you enough to get you going. As a developer in an Excel work environment, I have successfully developed many add-ins with Delphi 3, and I know of no one else doing this. There is Financial CAD, a Canadian firm whose add-ins can be used from Delphi, but I think they're written in C++. Hey, I might be the only person in the world doing this. Delphi add-ins make it easy for you to extend Excel in many ways, such as data capture from serial ports, data feeds, all with the speed of Delphi compiled code, which is significantly faster than interpreted Excel VBA. Let's get started. There's a lot to cover. Huge strings are a huge mistake, as the add-in is a DLL and Excel uses short strings. You must ensure that the huge strings compiler option is clear, or $H used. You could probably use long strings internally, but make sure you convert before passing them to Excel. For further safety feature, use short string or string n types where n is 1 to 255. Even if you have huge strings enabled, you can use string n for parameter passing, as these are always of type short string. Just remember the golden rule: no long strings in past parameters or records. Recognition at last: Excel will only recognize your DLL as an add-in if certain functions are exported. You must always provide these functions, as well as those for the user. These XL Auto family of functions are listed in the table below and documented in the edbook and in the example code with this article. All of your exported functions must use the stcall calling convention. Function purpose XL Auto free called by Excel to free the addon's allocated memory. XL Auto add called when the addon is first registered. XL Auto open called when Excel loads. XL Auto close called when Excel exits. XL Auto remove called when the addon is removed from Excel. XL Auto register only called if a function hasn't been registered. XL Add-in Manager Info provides a text string description of the add-in. To use any built-in Excel function, your function calls the Excel function Excel4v. This is defined as function Excel4v, XLFN, Word, Opers, Lpsloper, Count, Integer, Opers, Array of Lpsloper integer, stcall, External slowcall 32.dll. XLFN is the function number of the Excel function called. Operfn is the result and is a pointer to an sloper called an lpsloper. See next section. Count is the number of elements in Opers. Opers is an array of lpsloper, i.e. an array of pointers to slopers. Note: for many function you can pass a null array for the Opers parameter. Under D3, the empty array construction is not allowed, as it is in D4, so use nil under D3. My development emphasis has been to give users new functions. The EDK documents how to add buttons and controls to Excel, but those are a little bit more work and I don't deal with them here. If you wish to push data into Excel, there are two other approaches. Both shareware-based. The TADV component has very fast data transfer using DDE. The TXLS read-write-read components can output data formatting and formulas direct into Excel workbook files. Before you start calling Excel functions, you have to know about the XL Overtype. This is a Pascal record, C struct, some 10 bytes in size, aligned on 16-byte paragraphs in arrays, which corresponds to cells in an Excel spreadsheet. The definition is shown below. Blame Microsoft for the brief field names. The table type uses the old Pascal variant record type, not to be confused with Windows OLE variants, though used in a similar way. The slow type field of XLOPER specifies which of the 9 types used is in play. So if the sloper has a type of 1, val.number has a valid double precision number. I've found that types 1, 2, and 8 are the most used. Type 4 is returned by Excel when you get something wrong. There is an integer type 5, but number 1 seems far more common. Type 6 is used for ranges, with type 9 for collections of separate cells where you hold the control key down when selecting cells. There is no type 7. Sloper definition tval equals packed record case byte of 1, number, double, asterisk slow type number, 2, str, caret short string, slow type str, 3, bool, word, slow type bool, 4, air, word, slow type air, 5, w, integer, slow type int, 6, sref, packed record count word, ref, slow ref, and 8, underscore array, packed record, slow type multi asterisk, lp array, lpxloper array, rows, word, columns, word, and 9, mref, packed record / slow type ref lpmref, lpslmref. It sheet, integer, and //tval xlo per equals packed record val, tval, slow type, word, dummy array 05 of byte, / pads to 16 byte size and, lpsloper equals caret sloper. Problem with Excel calls from Delphi. The big stumbling block with add-ins is the extra parameter after the return address on the stack. This comes free with every call to Excel. I've never found out what it holds, but so long as you throw it away, your add-in will work fine. Add the line ASM pop variable, and, after every call where variable can be any global, local, or object variable that is at least 4 bytes long integer is fine. To repeat this must be included after every Excel 4v call. Otherwise you are constructing a time bomb. Example airsult equals Excel 4v, xlf caller at xrs0 nil, asm pop sync, and / never remove. Note that with Delphi syntax, if xrs is in sloper, you can use at xrs to define an lpsloper. Caution recalculation alert. If the inputs to your function are calculated in any way, your code should check the status of the Excel call, airsult in the example above, as well as the result of the Excel function call, which will be in xrs above. Remember, you call Excel 4v to calories the specified function. Airsult gives 0 if OK, or a bit set to indicate errors. You should always handle the values 1 and 64. 1 is slayboard indicating the user pressed the ESC key. 64 is an uncalculated cell reference. It's not an error, but happens when your function uses functions or calculations on the worksheet that are fully evaluated after your routine is first called. If this happens, your code must free up any memory already allocated in the call and exit. Excel will call your function again. Structure your code like this one. Get input parameters too. If an error 64 or 1, abort key, occurs, exit after freeing up any memory already allocated, if any, in this function. 3. Do main function processing. If step 3 is going to be very time-consuming, say more than 1/10 of a second, your code should check the abort status by calling xlabort periodically. Start up when the add-in is first added to Excel. Each of the exported functions must be registered. This involves calling the Excel register routine for each routine. There are 8 parameters passed as XLOPers. Parameter type: use module text string full name of DLL with path procedure string or number function name or number to call type text string argument and return types function text string function name in function wizard argument text string optional text string that describes parameters in function wizard macro type number 0, 1, or 2 category string or number category under which function appears shortcut text string only used for commands. Pass in null for function. The most important parameter to register is the text type. This uses the letters AR to represent the return value and the supplied parameters. Values are passed as you'd expect in a C API by reference, i.e. pointer, which is always an sloper, or by value. E.g. the Excel spreadsheet equals my function, a 1b1, passes a reference while equals interest rate, GBP, uses a value. Example: DLL name equals get name, / function to return name / path from Excel px module text dot set str, s, / note, 1, px procedure dot set str, add date, / function name px type text dot set str, jjdd, / 2, type return equals j, input equals jdd px function text dot set str, add date, / name in fx wizard px argument text dot set str, date period currency, / parm text in fx wiz px macrotype dot set number, 1, / type equals simple func, 3, px category dot set str, add in category, / category for func. Wiz result equals Excel 4v, slope register address 8, // pass in 8 parms px moduli text.thelp sloper, px procedure.thelp sloper, px type text.thelp sloper, px function text.thelp sloper, px argument text.thelp sloper, px macrotype.thelp sloper, px category.thelp sloper, slope sloper, / null asm pop sync, and / never remove result equals trunk, res.val.number, / id code. 4. The px variables are all of the t-sloper class, which simplifies initializing slopers. Notes: 1. The DLL name and path should be obtained from Excel. Via the Excel getName function you can see this used in the example code. Do not hard-code it as it includes the path. 2. See Register, page 219 in Ed.K, for fuller details of text type. The first parameter is the return parameter, j equals 32-bit integer. The next 3 are inputs, jdd equals integer, string, and the means that Excel always calls the function when it recalculates. Without the, Excel calls the function once, latches the result and uses the latched result on later calls. 3. Type 1 equals function. Other types include unlisted function, type 0, and commands, type 2. If you want functions that don't show up in the function wizard, use 0. 4. After successful registering, the numeric value in res.val.number, contains an integer ID code for this function to handle. Save this and pass it to the unregister function when the DLL is closed. Forget this and you'll have trouble using newer versions of the library. Getting values from an Excel spreadsheet. Values can be passed in 3 ways. 1 as a passed by value, e.g. equals calc mean, 4,5,8, slow type enum or slow typester 2. As a simple reference, say a cell A1 or range A3 B56. Slow types ref 3. As a composite reference. Basically a collection of disjoint cell references. Slow type mref 1 and 2 are the most common. 3 is a bit weird, and unless really needed, it is better to filter out this. If you want to use it, the input is an array of cell references, type 2, so you have to use each one. Excel will filter the data type if you specify it, number, string, etc., but if you expecting a range, then you should fully check the type and ranges of values, reporting errors if appropriate. Returning errors. Your function must return an sloper, type R, if you wish to return Excel error codes. To set an error in res, and sloper, just do res.slowtype equals slowtype here, res.val.error equals number, / returns following values, then just return at res from your function number Excel error 0 #null 7 #div/015 #value 23 #ref 29 #name 36 #number 42 #n/a with complicated many parameter functions. I think that standard Excel errors are a little unfriendly, and so I strongly suggest a getLastError function which returns the last error string. Any function which returns an error should set the error string returned by getLastError. This will save users a lot of time when they are using your functions for the first time. Reading cell values. Having been passed a cell reference, slowtypes ref, you want to get at the values contained in the cells. To do this, you must coerce the cell reference sloper. This coerce, an Excel function, forces Excel to construct a vector of slopers, with exactly #rows * #cols, slopers. I.e., for a 2x3 array of cells, you get 6 slopers. The target sloper becomes a header with the slowtype field equals 64, slowtype array. The val_array member contains the number of rows and columns and a pointer to the body sloper. These slopers are arranged in row order, so the 6 cells in 2 rows by 3 columns is stored as 1 2 3 4 5 6. Each will have the fundamental type, slowtype number or str, and the value. Example of coercion: desttype.slowtype equals slowtype int, desttype.val.w equals slowtype multi, airsult equals excel4v, slow coerce at idle2 values at desttype, asm pop sync, and // never remove the slopers. Slopers used here are desttype and sloper that specifies the coercion destination type, slowtype multi. Excel's name for an array of slopers, values, the passed in cell reference and sloper idle, the target sloper. After a successful coerce, this is the header of an array. With the 2x3 array, there will be 6 slopers, each holding a cell value. Excel has allocated memory on your behalf, and this has to be dealt with, but more on that later. Example of using the values. This example checks the if idle.val_array.rows1 then begin error, should only have one row, go to my exit, and slur equals idle.val_array.loop array, index equals 0, for col equals 1 to xr dot number calls do begin if slur caret index dot slow type enum then begin error element plus into row plus not a number break and value col equals slur caret index dot val dot number inc index and slur is a pointer to an array of slopers. In this example, this checks that there is one row of non-numeric data. It then copies the values into the value array. Putting values into Excel cells, although there is an equivalent, sort of slowcores, called slowset, it can only be called from a command, menu or toolbar button, and not from a function. It's very antisocial anyway to just dump a bunch of values into a spreadsheet. It might just overwrite a morning's unsaved work, and won't that improve your popularity? A not so well known feature of Excel called function arrays, or formula arrays, is what is needed. If you aren't familiar with them, try this on an empty Excel sheet. 1. Select a rectangular area with the mouse. Now click on the editing line, just below the toolbars, above the cells, and type in equals G1. At this point you should see equals G1 in the edit line and the selected area should still be selected. If you cleared the selection by mistake, go back and try it again. To now hold down Ctrl and Shift keys and press Enter. The equals G1 should be pasted into all cells in the previously selected area. You should also notice some things about this if you click on any cell in this area. 1. The edit line shows the equation in brackets. 2. You cannot change or clear the cell. 3. It didn't adjust the cell reference. This is the only way, so far as I could work out, to put values into Excel cells. Your Excel function must build up an array of slopers, with the header pointing to the body. If your function returns an array, you must use a function array to show the result. Excel is quite clever with this. If you return a 3x5 area and the user pastes a function array into a 4x6 rectangle, the extra cells will all show n/a memory management if an Excel 4v call returns an sloper with a pointer, strings or slow type multi for instance, then, when your code has finished with the value, your code must always call slowFree on the sloper. In fact, as a general rule, calling slowFree on any sloper does no harm at all. There are 2 memory allocation cases that your code must handle. 1. You have called a routine that returns an sloper with data in it, e.g. slowcores to convert a slow types ref/slow type ref to an slow type multi array. Excel allocates its own memory, and when you are finished with the data, you should enter in the value $1,000, 4096 decimal, to the slow type. This $1,000 value is known as slow bit Excel free. When you call slow free, it frees up the Excel allocated memory. 2. If your code returns an array of slopers which Excel shows as a function array, you must enter in the value $4,000, 16,384 decimal, to the slow type field, before the function exits. After copying the values, Excel will do a callback to your Excel auto free function. You did implement one, didn't you, with an sloper to your data. You can then free it. If you created the array with n elements, in n+1 slopers, where array name 0 is the header which points to array name 1, then the pointer returned points to array name 0, and free mem, callback pointer, will then free the correct pointer. An example add in the example accompanying this article is self-contained in about 650 lines of code with no non-Delphi components or units needed. It implements a cumulative distribution function getCDF that takes a number in the range -4 to 4 as input and returns the height under the ogive curve. I know that Excel comes with several normal distribution functions, but it serves as an example. It has been tested on Excel 95 and 97 with Delphi 3 on Win 95 98 and NT and proved to be rock solid. I cannot stress how important it is to check all inputs and try and get your code as rugged as possible. Anything nasty will probably bomb or hang Excel, and users will rapidly become abusers. Don't forget the Dlls on all exported functions. Apart from the obligatory Slotto family of functions, it includes 5 other functions, 2 of which are invisible. These 2, getXL stack and freeRAM, are meant for use by the developer only. The other 3, getCDF, LastError, and version, are for the user. You can use both types of functions directly, but only visible ones will be seen in the function wizard. And don't forget the brackets on function calls. Excel will happily take equals version, without, and return a value of -30408699. I've no idea, when you actually meant equals version. I've included just the main Excel function numbers used in the program. The full list has nearly 400. The EDK has the whole lot and includes C headers that can easily be edited. In many ways this is a bit of an old-fashioned, non-OOP program. I chose that way originally as I was feeling my way round Excel add-ins and I didn't want to have problems with objects at the same time. The only class I've used here is tsloper for simplifying creating slopers, but that was to keep it concise. Send your queries and work offers to david@darkgames.com. The file below is complete. Source for a DLL. Make sure the extension is .xll$a plus b-c plus d plus e-f-g plus h-i plus j plus k-l plus m-n plus o-p plus q plus r-s-t-u-v plus w plus x plus y-z1 library. Calc uses SYS Utils, Windows, Dialogues, Forms, Classes, Math, //slowref structure type slowref equals packed record RW first, smallint, RW last, smallint, COL first, byte, COL last, byte, and // returns a range of selection XL range record equals packed record count. Word, / should always be $1 sref, slowref, and slmref equals packed record count. Word, ref tbl, array 0 1000 of xlref, and lpsloper equals /sloper, lpsloper array equals $xl array, lpslmref equals $slmref. Tval equals packed record case byte of 1, number, double, / slow type number 2, str, short string, / slow type str3, bool, word, / slow type bool 4, air, word, / slow type air 5, w, integer, / slow type int 6, sref, packed record count, word, ref, slowref, and 8, underscore array, packed record / slow type multi-lp array, lpsloper array, rows, word, columns, word, and 9, mref. Packed record / slow type ref lpmref, lpslmref, itsheet, integer, and / tval sloper equals packed record val, tval, slow type, word, dummy array 05 of byte, / filler and /array equals array 0 1000 of sloper, lpslarray equals /array, tsloper equals class / simple sloper support class private sloper, sloper, f actual str, short string, function get lpsloper, public constructor create, destructor destroy, override, constructor create _str, new str, short string. Procedure set str, new str, short string. Procedure set number, new number, integer. Procedure set int, new number, integer. Procedure set air, property thelpsloper, lpsloper read get lpsloper, and / excel function excel4v, xlfn word, opers lpsloper, count integer, opers array of lpsloper integer, stcall, external slowcall 32.dll, / slmref structure describes multiple rectangular references. Const slow type number equals $0001, slow type str equals $0002, slow type bool equals $0004, slow type ref equals $0008, slow type air equals $0010, slow type flow equals $0020, slow type multi equals $0040, slow type missing equals $0080, slow type nil equals $0100, slow type sref equals $0400, slow type int equals $0800, slow bit excel free equals $1000, slow bit DLL free equals $4000, slow type big data equals slow type str or slow type int, / error codes used for val.err field of sloper structure slayer null equals 0, slayer div 0 equals 7, slayer value equals 15, slayer ref equals 23, slayer name equals 29, slayer number equals 36, slayer NA equals 42, / return code slow ret success equals 0, / success slow ret abort equals 1, / macro halted slow ret invxlfn equals 2, / invalid function number slow ret inv count equals 4, / invalid number of arguments slow ret inv sloper equals 8, / invalid oper structure slow ret stack overflow equals 16, / stack overflow slow ret failed equals 32, / command failed slow ret uncalced equals 64, / uncalced cell / function number bits xl command equals $8,000, xl special equals $4,000, xlintl equals $2,000, xl prompt equals $1,000, / special function numbers xl free equals 0 or slow special, xl stack equals 1 or slow special, xl coerce equals 2 or slow special, xl set, sad face. 3 or slow special, XL sheet ID equals 4 or slow special, XL sheet NM equals 5 or slow special, XL abort equals 6 or slow special, XL get INST equals 7 or slow special, XL get HWND equals 8 or slow special, XL get name equals 9 or slow special, XL enable XLMSGS equals 10 or slow special, XL disable XLMSGS equals 11 or slow special, XL define binary name equals 12 or slow special, XL get binary name equals 13 or slow special, / user defined functions, needed for calling Excel functions XLF caller equals 89, XLF register equals 149, XLF unregister equals 201, / DL version short string equals CDF calc v1.02. Add in category equals CDF calculator, const slope sloper equals LP sloper, nil, type retare equals array 0 1000 of sloper, pret array equals caret retare, var / global data res, sloper, getf underscore id, integer, slow stack underscore id, integer, result, integer, sync, integer, get stack underscore id, integer, lasterer underscore id.